So for this one, a very simple question to start us off with. Find f prime of x. This is just power rule here. So f prime of x is going to equal 5 x to the fourth. That's it. We're done. We found f prime of x. All right. Now find f double prime of x. That means the second derivative. So in other words, the derivative of the derivative. All right, so when I do that, then I'm going to, again, use power rule. So I'm going to multiply the 5 by the 4, which is going to give me 20. And then I subtract 1 from my exponent as before, so that gives me 20x cubed. And you can find the second derivative that way. Notice the notation for second derivative is it's just 2 primes. We'll sometimes call it the second derivative. We'll also call it f double prime of x. And you can even keep going with these tricks. We can find the third derivative. Okay? Do that, please. Please find the third derivative of f of x here. All right, so to find the third derivative, that means that we're going to find the derivative of the second derivative now. And so that's going to give me 60x squared. And as you can imagine, we could keep going with this, right? Like, we could even go out to finding the 100th derivative. Okay, this should actually be a really easy one. Take a moment, figure out what would the 100th derivative of this function be. Now I said it was easy, but I know some of you are looking at it like, wait, what? This is hard now. But it is easy, because if I start thinking about finding the derivatives of this, right? The first derivative, I get a number times x to the fourth. The next derivative is a number x cubed, then a number x squared, then a number times x, then just some number, right? Even if I don't know this number, I have some number that's just a constant. What's the derivative of that constant going to be? And what's the derivative of 0 going to be? And so no matter how many times we take the derivative of 0, we will get 0. And so the 100th derivative is 0. So then, now we're going to be jumping in and taking a look at tangent lines today. This is going to be the main theme of today's work. So please write down this problem, and then we're going to work it through together. All right, so for doing this problem, the very first thing you'll note here is we are writing the equation of the tangent line. As soon as you see that word tangent, you should be thinking about something very important. How do we always find the slope of a tangent line? Yes, derivative. Where, remember, at first we had to do difference quotient and find the limit as h approaches 0, but now we can just find the derivative like using power rule and things like that. So I know I'm going to have to find the derivative of this. Specifically, I need to know what's happening at x equals 3. So I'm going to find the derivative. I'm going to see what the derivative is at 3. And I'll tell you one other thing. You also need to know what the actual value of f of 3 is. Go ahead and find each of those, and then we'll see why we need each of them and how we put them all together. And here you can check your work for each of those calculations, making sure that everything came out right along the way. All right, now we did this work because we needed two particular numbers. We needed first to know what f prime of 3 equaled, and we needed to know what f of 3 equaled. Each of these represents different things, remember. And so it's going to be a matter of knowing what do these really mean that's going to allow us to go and find our equation. So let's focus just on those pieces and the fact that we're trying to write linear equations here. And there's two different forms that you can write a linear equation in. Or, well, at least two very common forms that you might go to. The first is the good old school slope-intercept form here. We could write our equation in slope-intercept here, but if you want to be a little bit extra fancy, you might use point-slope form over here. And we're actually going to go through how to do this problem either way. So let's start with the first one, the slope-intercept here. In order to write the equation in slope-intercept form, I need to actually plug in all the values in order to be able to find b. That means I have to know what y, m, and x all are. So in this particular problem, what is the value of y? The value of y is 7. This is why we went and we figured out what f of 3 was, because f of 3 is just the y value that goes with the x-coordinate of 3. And we need to know that in order to be able to write this equation, in order to be able to find out what the y-intercept is. All right, then, the next thing we put in there is the m value, the slope. What is my slope here? Yes, it's 4. Because remember, that's what derivative tells us. Derivative tells us the slope. And so that's why we also had to find out what f prime of 3 was. So that's why we had to find both of them. And notice the big distinction between knowing which one represents what. So my derivative tells me my slope. My actual function value, that's just the y-coordinate. All right, so I got 7 equals 4 times x. What's my x-coordinate in this problem? 3. Yep, that's the part that we started with. And then plus b. And we can solve for b from there. So let's go ahead and finish that out. So then that will be 7 equals 12 plus b. I can subtract the 12 from both sides, so negative 5 equals b. So this final answer then would be y equals 4x minus 5. But of course I said you could do it 2 different ways. So the other way is our point slope form over here. So let's say we're going to be writing the equation that way. Well, then it'd be y minus my y-coordinate. What's the y-coordinate again here? 7, yep. Equals m, that's the slope. What's my slope again? 4, yep. Times x minus the x-coordinate, which again was 3. If we were going and writing this equation in point slope form, we'd be done. That is the equation in point slope form. Now, it just said write the equation. It didn't specify a form. Let's say you started with this, but then noticed that it needed to be in slope-intercept. You can do that as well. So if you wanted to then take that and put it into slope-intercept, you can. You just add that 7 to both sides, and we end up in the same place. Notice it actually took us a little bit less work to get there. But oftentimes we forget about point slope form here being an option. We really latch onto this because we've known it for so much longer, but you can kind of see here that this is pretty helpful. So I would suggest that you gain some fluidity with that form as well. Now in this particular question, it just said to write the equation of the tangent line through that point, and we got our equation. Y equals 4x minus 5, or our point slope form there. That's our final answer. That's where we stop. That's all we are looking for. Having seen us do that one together, I'd now like you to go ahead and practice this idea on your own. So please write the equation of the tangent line to the curve for this. All right, so for this one, our method was the same as what we did on that last one, right? Where we just wrote the equation of the tangent line. Just different equation, different x value, same idea. But we also are going to be doing a little bit more with the tangent lines. I'm going to be doing one other type of problem with you today, so we're going to do this. We're going to do 2 different versions of this one, where we're going to take a look at this function, and I've sketched the graph up there so you can kind of see what we're dealing with. And we're going to try to find the coordinates of the points where the tangent to the graph is horizontal. And so I gave you the graph partly because I want to help connect this up to something concrete here. So what I'm looking for is where the tangent is horizontal. So it looks like that's going to happen up here. And it looks like that's also going to be happening, oops, if I can draw that a little bit better, over here. And so really what we're looking for is those 2 lines and the coordinates of the points where the tangent is horizontal. So that means I'm going to be then looking to see what's the coordinates of that point and what are the coordinates of that point. Those are my answers that I'm expecting to be able to find here. All right, so if I want to know where the tangent is horizontal, what am I going to actually use to find that? Well, what do we use to find slope of the tangent line? Derivative. If the slope is horizontal, so our line is horizontal, what is the slope equal? What's the slope of a horizontal line? 0. And so we're looking to see when that derivative, the slope, equals 0. And this is a general rule, might even be worth making note of here, where if I want to find where the tangent slope is 0, I'm solving f prime of x equals 0. And then once you've made note of that, then that's what we're going to do on this, is we're going to find the derivative, and then we're going to set it equal to 0 and solve it. All right, so the first thing we do here is we find that derivative, and then we set it equal to 0. And so notice that we're basically solving a quadratic now. So now, in order to be able to solve this problem, we have to utilize our quadratic skills. Well, I'm hoping to not have to use the quadratic formula here, just because I find that to be a pain. Ideally, we'd be able to factor it. So check to see, can you factor that quadratic to find the solutions? And as you're looking at doing that factoring, I hope the very first thing you noticed is that all 3 of those coefficients are divisible by 6. If you start by factoring that 6 out, it's going to be a lot easier to see if this is factorable. And so it is factorable, thankfully, so we don't have to resort to quadratic formula or anything more complicated like that. In fact, our resulting quadratic after factoring out the 6 is actually fairly straightforward. We're just adding to negative 13 and multiplying to 40 to get that. And so it's negative 5 and negative 8. Remember, to find the solutions, we set each of those 2 sets of parentheses equal to 0. So what minus 5 equals 0? Positive 5. And of course, what minus 8 gives us the positive 8. All right, so now that we know our 2 x values, we're basically halfway there. Because remember, we're trying to find points where the tangent line slope is 0. I now have the x coordinate of each point. But now that I have the x coordinate of each point, I need to find the y coordinates. So what do we do to find the y coordinates? Yep, we plug it in. And for whatever reason, when we start into these problems, because we're working with both original function and derivative, really make sure you think through what means what here, because sometimes people will go and plug this back into the derivative. That won't help us any. We want to know what the actual y coordinates are. The y coordinates are determined by the original function, so that's why we're plugging into f of x. So find f of 5 and find f of 8 if you haven't yet. And so when we do plug in those values of 5 and 8, we go and find the corresponding y values. Yeah, they're up in the 400s, but such is the way with these. And so we end up finding our 2 points, 5, 471, and 8, 444. Those 2 points were what we were looking for, because remember, the question asked us to find the points at which the slope of the tangent line would be 0. Or in other words, where the slope of the tangent line is horizontal. Now, again, what does this really mean? I want to bring us back. We can actually see, if I go back to that same graph that I started with, that you can see that those are the actual coordinates of those points that are represented there. That's what we're really finding and what it's really doing for us. So then our last problem for today is going to be this one, where I'd now like you to follow that process that we just went through on that last one and do it on your own here. Find the coordinates of the points where the tangent to this curve is horizontal. So the first thing you do is you find the derivative, because of course we're dealing with tangent slopes. That always tells us work with derivative. And then once you find that derivative, set it equal to 0. So this is what your first step would be looking like, or perhaps your second if you're writing out a little bit more detail, which is good. Then we solve that equal to 0, which in this case means trying to factor our quadratic, and thankfully it does factor very nicely. And so we can find that x must equal 8 and 4. Do not forget, I'm looking for the points, the coordinates of the points, so I need both the x values, which I found, and the y values, which I would next go and find. Now when I go to find those y values, remember I'm plugging back into the original f of x, because f of x means y. That actually tells me my y coordinate there. And so make sure that you are plugging in the 8 into f of x, and the 4 into f of x, not into the derivative functions there. And when you do that, these should be our 2 points that we're looking for, and therefore our final solution.